Hello students. So this is all about the quick revision of the periodic table as tentative timetable for ICSE class 10 exam has revealed. So when I'm going to discuss these quick revision classes for each of the chapters of your class 10 ICSE chemistry. So we are going to start with the periodic table that is called modern periodic table. So in this chapter we are going to discuss about modern periodic law, periodicity, variation in periodic properties like atomic size, metallic character, non-metallic character, ionization potential, electron affinity and electron negativity. So all these topics will be covered in this particular class. So stay tuned. So first of all, modern periodic table is discovered by Henry Moseley, right? Henry Henry Moseley. Okay. So while studying X-ray, he observed some points regarding the Mendeleev's periodic table. Then she modified some things from the modern periodic table and from the Mendeleev's periodic table, and then derived the modern periodic table, which is the periodic table now you can see in your book and uh, wherever you can find it. So the modern periodic table is based on the fundamental concept that is called your atomic number. Okay, atomic number. That means modern periodic in modern periodic table the elements are arranged into or arranged in the increasing order of their atomic number. So on that note we can write the modern periodic law. As this is revision class, we are not going to discuss into so deeply, just the main points which are very essential for your exam. So modern periodic law. Okay, modern periodic law. So what is modern periodic law? The physical physical and chemical properties physical and chemical properties are the periodic function of the physical and chemical properties of the elements are the periodic function of their atomic number. Atomic number. That means this atomic number defines the physical and chemical properties of an element. So in other words, we can say the elements are arranged in the increasing order of their atomic number. Okay, increasing order of their atomic number. Understood? Now, what are periodic function actually? Periodic function means the properties like physical and chemical properties repeat itself after a certain interval of time, which is also known as periodicity. Which is also known as periodicity. So, what is periodicity? A reoccurrence of properties at a interval of time. Regular interval of time. So this is what periodic or periodicity means. So in standard 9 or in standard 10 also you have studied about the groups. Okay, how all the elements in a group follow the same properties. So this is basically the periodicity. I hope you understood this concept. Now we are going to move to the variation in periodic properties. Variation in periodic property. Variation in periodic property. So these things are very simple in generally. So if you want to understand the concept only, these are very simple. First of all, let us understand what is atomic size and how it varies. Okay. So देखो, atomic size means that is basically the size of the atom, and it depends on the atomic radius or atomic radii. Okay. That means the distance between nucleus to the outermost cell. This is called atomic radii. Okay. So if this atomic radii will increase, definitely the size of the atom will also be increased. Understood now? So we can now understand, or we should understand few concepts like how atomic size affected on moving left to right and on moving top to bottom. So to understand that, we have to understand one term that is called nuclear charge. Okay, that is called nuclear charge and how it affects the size of the atom, right? So nuclear charge is basically the attraction force of attraction of nucleus towards the electrons revolving around it in circular paths called orbits, right? Called orbits. So force of attraction of the nucleus towards the euclidean. Why why this force of attraction will exist? You see, suppose this is the nucleus. So inside the nucleus proton is there and neutron is there. Okay, and suppose electron is there. So proton is positively charged, positively charged. Okay, and electron is negatively charged. Okay, electron is negatively charged. So this is positive and this is negative. Okay, so definitely there will be force of attraction between the positive charge and the negative charge. This force of attraction is called nuclear charge. This force of attraction is called nuclear charge, or in generally you can call it also electrostatic force. Electrostatic force. Okay, electrostatic force. Understood? So now you see, when the number of electron will be more and the number of proton will be more. Let's say, let's take an example of let's say sodium, right? Let's say sodium. So this is the nucleus of the sodium and it has three cells, right? So in first cell, so this is K, L, M. So the first cell 2 electrons are there, second cell 8 electrons are there, and third cell 1 electron is there. Similarly, let's understand for chlorine. This is 1, 2, and 3. Okay. So in this case, it also has 3 electrons, that is KLM, 2, 8, and 7. Okay. So in this case, number of proton is equal to 11, electron is equal to 11. In this case, number of proton is equal to 17 and electron is equal to 17. You see, use your common sense. As the number of electrons and protons are less here, so force of attraction will be less this side, and the force of as the protons and electrons are more here, so force of attraction will be more this side. So on moving from left to right, nuclear charge increases, right? nuclear charge nuclear charge increases. Okay, nuclear charge increases. As nuclear charge increases, the the cells will be shrinking towards the nucleus. Hence, on moving towards left to right, atomic size decreases. Atomic size decreases. Understood? So it's a very simple concept. On moving left to right, nuclear charge increases, which results in the reduction of the atomic size. Which results in the reduction of the atomic size. Understood? Next, moving from top to bottom. Okay, moving from top to bottom. Okay, moving from top to bottom. You see, on moving top to bottom, number of cells will increase. Number of cells will increase. As number of electron will also increase. Though number of electron will also increase, as well as number of cell will also increase. Okay, number of cell will also increase. So I can say for lithium and sodium, okay, and potassium. Let's understand all these three. So one, this is first cell, and this is second cell. The electronic configuration will be 2 and 1, right? And for sodium I can write first cell, second cell, and third cell. Okay, first cell, second cell, and third cell. So the electronic configuration is 2 8 1. And for potassium I can write 1 2 3 and 4. You see, the electronic configuration here is 2881, right? So clearly you can see, as the number of electrons increased, the number of cells also increased, and the size also increased. Okay, the size also increased. Understood? So this is why on moving top to bottom, atomic size atomic size increases. Okay, atomic size increases. You don't need to remember how it increased. The question will be like this. Let's say suppose potassium, lithium, sodium, and francium. Arrange these in according to the increasing order of their atomic size. So increasing order means small to means smaller to greater. So first lithium, then sodium, then potassium, then francium. So this is how questions will be there in a board exam. So you just need to understand that the atomic size on moving left to right will decrease, and on moving top to bottom will increase. Okay, and reason will be left to right nuclear charge increases, hence atomic size decreases, and top to bottom number of cells increases and the size also increases. Hope you understood how the size of the atom changes on moving from top to bottom, right? So let me clarify once more. Top to bottom atomic size increases. Okay, atomic size increases, and left to right atomic size decreases decreases till till 17th group. Okay, till 17th group, because 18th group elements are stable. Okay, hence their size won't be decreased. Okay, their size won't be decreased. So now next move on to metallic and non-metallic character. First of all, let's understand metallic character. Metallic character. So metallic character means definitely we're talking about metal, right? Definitely we're talking about metal. So metal is one which loses electron, right? Metal is one which loses electrons, right? Which loses electron. That means if the force of attraction will be less, then it will be easier for the atom to lose the electron. Yes or no? But if the force of attraction or if the nuclear charge will be more, it will be difficult for an atom to lose the electron. Let's understand fast. Suppose this is sodium here, and this is, let's say, francium here. So it will have 7 cells, right? And it will have 3 cells, and here we should write chlorine. It will also have 3 cells, but you see clearly the size of this will be greater. That means the size of francium will be greater than the size of sodium. That means the distance from the nucleus to the outermost cell is much more than the distance of the nucleus to the outermost cell in sodium. This is for sodium and this is for francium. And for chlorine, age cells remain same, but number of electrons are more. Hence, the nuclear charge is more in the direction. Nuclear charge is more. So, nuclear charge is more, then size is also less. So, the distance between this two last cell is very less. Okay, is very less, and force of attraction is more. Force of attraction is much more. Hence, it is difficult to, or it is difficult for chlorine to lose the atom. Also it is difficult for sodium. If I are comparing it with francium, it will be difficult for sodium to lose the electron, but it will be much more easier for francium to lose the electron. Hence the elements which are at the bottom of the periodic table can easily lose electron. So we can say that metallic character from top to bottom increases. Okay, and left to right, as it is very difficult for the elements to lose the electron, hence the metallic character from left to right decreases. Understood? So on moving top to bottom, metallic character increases. On moving left to right, metallic character decreases. I hope you understood. Similarly, if you are talking about non-metallic character, is now it is a complete common sense. Non-metallic character, okay, non-metallic character, I can say, if on moving from top to bottom metallic character increases, then definitely non-metallic character will decrease. Similarly, if moving left to right metallic character decreases, then non-metallic character will increase. Did you understand? Because nonmetals are the elements which accepts electron. The atoms of the nonmetal accepts electron, they don't lose electron, hence they won't lose electron. If they are not losing electron, that means they are nonmetals, right? So on moving top to bottom nonmetallic character decreases, and moving left to right nonmetallic character increases. Clear? So these are some basic properties. Now we are going to discuss about some important properties like ionization potential. Okay, ionization ionization potential. Okay, ionization potential. So what do you understand by ionization potential? It is also known as ionization energy. It is also known as ionization energy. Okay, now you see what is ionization potential. If you can define it, you can write energy energy required to remove an electron from the outermost shell of an isolated gaseous atom. Okay, from an isolated gaseous atom. Don't understand, sorry, don't consider the isolated gaseous atom means only gaseous atoms. Okay, so these can be metals, non-metals, everything. In terms they ionize, hence it is, they are called isolated gaseous atoms. So we are not going to discuss much about that. Let's understand for sodium again. Sodium has three cells, right? Sodium has three cells. Similarly, potassium potassium has four cells. One, two, three, and four. You see, the size of potassium is more than the size of sodium. Hence, from this atom, electron can easily be removed. Means less energy will be required for potassium and more energy will be required for sodium to remove the electron from its outermost shell, right? So when the electron will be removed, it will become positively charged. Here also same, when the electron will be removed, it will become positively charged. But the point is, where we need more energy and where we need less energy. Okay, so you can see sodium is in third period. Okay, sodium is in third period and potassium is in fourth period. So on moving down, the size of the atom increases and it is easier for an element to lose the electron. That means less energy is required. Hence on moving top to bottom, ionization potential decreases. On moving top to bottom, ionization potential decreases. Similarly, when I'm moving left to right, non-metallic character increases. That means the atoms won't lose electrons. Hence, more energy will be required. Yes or no? So IP will increase on moving left to right. Did you understand? Once more, if the size of the atom will increase, the distance between nucleus to the outermost cell will also be increased. Hence it will be easier for an atom to lose the electron, right? Because the nuclear charge will be less because the size of the atom is more. Similarly, for on moving from left to right, the size decreases and in nuclear charge increases, so it will be difficult for an atom to lose electron. Hence more energy will be required to take the electron out from the outermost shell of an atom. Hence ionization potential increases from left to right and decreases from top to bottom. This is what ionization energy is, and the question will be as similar as I told. It will be asked to arrange the elements in order to increasing or decreasing order of their ionization potential. Next point, electron affinity. Electron affinity. Okay, electron affinity. So electron affinity is also a kind of energy. In this, in the last case, the energy required. In this, energy released. Energy energy released when an electron is added to the last cell of an isolated gaseous atom. Isolated gaseous atom. Okay, isolated gaseous atom. So this is electron affinity, the amount of energy released when an electron is added to the last cell of an isolated gaseous system. Now let's understand, okay, the amount of energy released. So in this case, electrons can easily be added. Electrons can easily be added, but in this case, it is not. Okay, in this case, it is not, because metal will try to lose the electrons. So it will be difficult for these to accept the electrons. Yes or no? So if they are easily accepting the electron, that means energy release will be less. But here it is difficult, that means energy release will be more. So in that case, electron affinity will decrease here and electron affinity will increase here. Okay, just like ionization potential, on moving left to right, ionization potential increases, on moving left to right, electron affinity increases, because easily electrons can be added, right? So hence ionization electron affinity is more, and because they attract electron affinity means the attraction, okay, attraction for the attraction for the electrons, right? Similarly, in this case, electrons cannot be added, so EA is less. Instead of understanding in that manner, you can understand this manner, that electrons can be easily added, hence EA is more, and electrons cannot be easily added, hence EA is less. So on moving top to bottom, electron affinity decreases, and on moving left to right, electron affinity increases. Understood? Now let's understand the last point, that is called electronegativity. Okay, that is called electronegativity. So what is electronegativity? Electronegativity is a process or the process of conversion of an atom to an electronegative ion or radical by accepting the electrons. Accepting the electrons. Non-metals can As we know, nonmetals can easily accept the electrons, yes or no? Hence, electronegativity will be more here, and metals cannot easily accept the electrons, so electronegativity will be less here. That means on moving top to bottom, electronegativity will decrease, and on moving left to right, electronegativity will increase. Let us understand what is means how they converted themselves into negatively charged ion. So chlorine will accept one electron to become electronically stable, so it will become 1 minus. If we are talking about francium, this is a metal, right? Very heavy metal, and it is at the bottom of the periodic table. As it is a heavy metal, so metal cannot accept electron. If you are writing 1e, so it is the wrong thing, because they only will lose the electron, okay, because they will lose the electron. Understood? They will lose the electron. Hence, on moving left to right, electronegativity increases, and on moving top to bottom, electronegativity decreases. Right? Hope you understood this discussion of the key concepts of periodic table. Okay, and rest is about how we are understanding and discussing the questions or revising the questions. According to that only, we'll be able to write the answers in the paper, right? So this is how periodic table over. We are going to discuss some questions of periodic table also. I hope you understood this chapter, and practice more and for your exam. All the best. All the best. Thank you.